Guys, I'm now back and will give you my full attention. So it's time to work and let's prepare for our first exam of mathematics this Friday. Now, what I'm going to do now here is a bonus question for question 10. So this is another type of question that you can get in terms of the application of calculus. And this type of a question looks at the concept of rate of change, what we call rate of change. Now, these types of questions are really unique and special to the topic of calculus. And that's why they will always be part of calculus, because they were the first questions that were studied for calculus to be what it is today. They are really the birth of calculus. These questions, Newton was studying motion of objects, Sir Isaac Newton, and he struggled in terms of solving those problems. Then eventually, as he was trying to solve those problems, he then invented calculus. He came up with calculus. And from there, a lot of people or mathematicians put their contributions and it grew to be what it is today. And I'm going to share with you actually what Newton came up with when he studied this part of calculus. The first thing that we need to understand is the concept of a rate of change. A rate of change in calculus simply means a derivative. So it is the same as saying the derivative. If you hear someone saying a rate of change, it means they're taking a derivative. Any rate of change would mean the derivative, and that means I will take the equation that I have and compute the derivative of that equation. Now here, these ones, they apply to motion, but you can apply them anywhere really, even in economics. You can apply them there. Now, in our situation, we have to understand a couple of things, and I need you to write these notes, just a quick revision in full. So there's a concept called distance that we need to know. And I think people who are studying physical sciences are at an advantage when it comes to this topic, because we really study these things when we study kinematics, which is the study of motion. We talk about these concepts. So I'm just giving everyone, even those that are not doing physical sciences, these notes so that you can be able to understand what we are doing here. Now, distance means the total length traveled by an object. So it's just, how far an object has traveled. And we usually in mathematics use a symbol S to denote distance. So in our equation, it will come as a symbol S. And it is measured in meters. So the SI unit that we use to measure distance is meters, usually written as just the letter M. Now, it is very then important to understand that distance can change with respect to time. In other words, I can write it as a function of time. So we can say this is a function of time. So as the time changes, the distance changes. And I mean, this is a very simple concept to understand, because the more, let's say, for example, you are walking, you will cover more distance the more you spend time walking. So if you are walking for 1 second, you will cover a certain distance. But if you walk for 2 seconds, your distance increases. If you walk for 3 seconds, your distance, continues increasing like that. So it's a function of time. It changes as time changes. So our time here is the independent variable and the distance becomes the dependent variable. Now, and already one can think that we can, sketch graphs of these things. That's why when you study projectile motion, we really sketch graphs of these things. The other concept that we have to understand is displacement. So displacement, really, what it is that it is the difference between the initial and the final position. So this looks at the positions that an object occupies. So normally, distance and displacement will have the same magnitude, will have the same number when you calculate them, except that you'll find that distance can only be positive, but when you come to a displacement, it is allowed to be positive and negative. That's the difference between them. I'm not going to go into depth why that is the case, but the ones that are studying physical sciences know the reasons, and we will talk about that when you study physical sciences. The other concept that we need to know is the velocity. and velocity is given by the symbol v, or we can say v with respect to time. So this means that it is a quantity that also changes with respect to time. It depends on time. Just to add here, the displacement and distance have the same symbol. We use the symbol s for them. Velocity is the rate of change. It is the rate of change of displacement. So we look at the rate at which the displacement changes. This then would mean that velocity is the derivative of distance. So of displacement. Now so another way of writing it really would be that we will say v is equals to ds dt, because we're saying it is the rate, the derivative of the displacement. Remember, displacement and distance have the same symbol. Or one can say here that v of t as a function of t is the same as the derivative s prime t, the derivative of the displacement with respect to time. Now, the other concept then that we need to understand, or we need to know really, is speed. And again, for speed, we use the same symbol. And so it means also we can say here is v of t, because again, it's a function of time. But speed, it is the rate of change of distance. So again, it's the rate of change of distance. It means it is the derivative of distance. So if we take the derivative of distance, we get speed. So you would see that it will be the same way in which we do the velocity. Again, the difference here would be that because speed depends on distance, it will always be positive. Remember I said distance will always be positive here. So the speed, it is the rate of change. It is the derivative of distance. So it means you'll always get a positive number because the distance is always positive. But velocity, it is the rate of change of displacement, and we said displacement can be positive or negative. So that means the velocity will then be positive or negative. And again, as I said, people who do physical sciences would know the reasons why that is the case. But if you are only doing maths without physical science, you don't need to know the reasons. Nobody's going to ask you that. But you just have to know that the other one is positive and the other one is negative. The next thing that we also have to do here or understand is acceleration. Acceleration is defined as the rate of change of velocity. So it means it is the derivative of velocity because it is the rate of change of velocity. And we use the letter A for acceleration, and it means here we're saying it's going to be the v dt because we're saying it is the rate of change of velocity. Or again, one can write it as well to be a function of time. So acceleration would be a function of time. It changes as time changes. It depends on time. So this means here I'm going to say this can be written as v prime t because we're taking the derivative of the velocity. Then we must get the acceleration. That is just the notation that we use to write these things down. I hope this was clear and it makes sense. Let's use this now to solve the problem that we have. Now, the problem that we have here says that a car moves between point A and point B. So we're having a car that moves between point A and point B. Just for me, maybe to do a sketch here where we can sort of have a visual picture of this. We are having point A here, and somewhere here we're having point B. And our car moves from point A and it goes to point B. It comes to this side here, so it moves between those 2 points. They say here the distance in meters. Remember I said distance will be measured in meters. Okay, maybe if I could quickly add on here to say distance is measured in meters and also displacement is measured in meters as well. Velocity and speed, both the velocity and speed are measured in meters per second. We use this symbol here, meters per second, because you are dividing meters with time, which is measured in seconds. and the acceleration is measured in meters per second squared. So you will say here meters per second squared, because we're doing rate twice here. If you can check here already, we're doing a rate on another rate there. Okay, so now we say here the distance in meters of the car is given by the equation. Then they give us this equation here. It represents the distance or the displacement of the object. So our equation that defines the distance or displacement is given by S as a function of time is equals to t to the power 3 minus 5t squared plus 4t plus 8. So this means this equation will tell us the displacement or the distance that an object has moved as time changes. It's a function of time. If you look at this, we know from calculus, this is a cubic function. Our variable here is t instead of x, because distance and displacement depend on the time. So this means that if I put different times here, maybe 0, 1, 2, all those times will give me different distances that the object moves in meters, right? And that's all that's happening here. Now here they say to us 10.1, calculate the distance of the car after 4 seconds. Now if the car moves from here, point A, and then it travels for 4 seconds, so if it travels for 4 seconds, the time here is 4 seconds. They want to know then what is this distance? Well, as I said, you can clearly see that this is a function. So we're going to look at the function value. We're going to say at t is equals to 4 seconds, our distance or displacement will be defined as t at 4. Then we're going to have here 4 to the power 3 minus 5, 4 squared plus 4 plus 8. And we can quickly just do this using our calculator really to save time. And this gives me an answer of 8. But remember, this is the distance or the displacement, so that means it will be measured in meters. So this means the distance from here to here will be 8 meters. So this would be like 8 meters after 4 seconds. And this is just 2 marks really. They will just give you a mark for putting in the x values, or rather your time, and getting the final answer. Now the next question says to us here, calculate the velocity of the car at t is equals to 10 seconds. Now obviously if they say we should calculate the velocity, it means we need to find the derivative of the displacement, because we said velocity is the rate of change of displacement. So here I'm going to say that my velocity with respect to time will be given by the derivative of our displacement, which then now it means I'm going to compute the derivative of this. Then when I do that, it will give me the velocity. So this means I'm going to have a 3 to the power 2. Remember, I take the 3 down here, then I subtract 1. Then here I'm going to have negative 10t. The 2 will come down here. I'm going to have a 2 times 5, that's negative 5, negative 10. And then we subtract 1, they're only going to be left with a t. And here we have invisible 1. I'm going to say 1 times 4. That should simply give me a 4. And we are going to say 1 minus 1 here, because the invisible 1 minus 1, when we do our rules, that is simply just a 4. And we know that the derivative of a constant is a 0. I'm not going to add anything there. Now, what I've done now is that I've found an equation that represents the velocity of the object at any time t. So if I put different times, I'll get those velocities. But our question actually requires us to find it at the time t is equals to 10 seconds. So we're going to say at t is equals to 10, we are going to have our velocity to be the function value of v at 10 is going to be 3 10 squared minus 10. Here I'm having a 10 plus a 4, and I can just use my calculator again to say 3 10 squared minus 10 times 10 plus a 4, and that gives me the velocity of 204 meters per second. Remember, velocity is measured in meters per second. And to do all this, it's about 3 marks. So 3 minutes, you'll get the mark for finding the derivative, another mark for substituting the time that you are given, and 1 mark for your final answer. I mean, these things, if you look at them, we have been doing them, just that we've been looking at them as if they're functions, you know. Now here we do a real life application where we solve problems of moving objects. Now the next question, which is 10.3, says calculate the minimum velocity. So they want us to get the minimum velocity of the car. Already we have an equation that defines velocity here. And we know that, you know, at the minimum, our derivative should be equal to 0. Meaning that we can look at this as a parabola and we want to find its minimum value. And actually to do that, we can take the second derivative of this and take that second derivative to be equal to 0 and explore or find what is the minimum value. Or because it's a parabola here, you can use the equation of a turning point, minimum turning point. You should be able to get it. Now, I'm going to just use a calculus approach since we are practicing calculus here. I'm going to say that in order for us to find the derivative, it means we're going to take the rate of change of velocity, which is actually the acceleration. So this means I'm going to take the second derivative of our distance there, right? Because this is the first derivative here. What we have here is the first derivative. Then if we take the second derivative, we should get acceleration. Now, to take the second derivative of this, it means I'm going to have a 6t minus 10. It's just a minus 10. Remember, this one here would be to the power 0, which is then it's going to give me 1. So that's my derivative. But at minimum, when minimum occurs, we know that when we have a minimum, at minimum, when minimum occurs, we are going to have our acceleration in this case, or our second derivative of this displacement to be equal to 0. So that means here the 6t minus 10 is equal to a 0. And this would mean that t is equals to 10 over 6, which will reduce down, I think, here we can say 2 into 10 goes 5, and into 3, it goes, into 6, it goes 3 times. Maybe we can find the decimal form of this. One can leave it at 1.67, I suppose, and this is seconds. Now, the time that we have found here is the time that occurs at the minimum. And we know that this function has a minimum turning point because our 3 there is positive, it's a happy graph. So it will have a minimum turning point here. Hence, I said you can actually use this equation here of a turning point. You should get the same answer if you do that. But I'm not going to do that in this question because I want to practice calculus. But try it and see if you get the same answer. What we can do here is that we can confirm if this is a minimum, we can confirm if this is a minimum using the first derivative test, where now we are going to then say we are having our derivative here, and we say we have a 0.5 over 3. And we know at this point that the tangent will have a gradient of 0 because it's where it is the turning point, the gradient will be 0. So it will be a parallel line. It will be a line parallel to the x-axis. And I'm going to test values that are less than 1.67 here. Maybe if I take a 0, for example, on our derivative. So that means if I put the time to be 0 here, what do I get? So you can see that if you put a 0 here, this thing will disappear and we get a negative number. Now that means our tangent, remember our tangent and the curve have the same gradient. So that means our tangent will have a negative gradient, or our graph will have a negative gradient. So this means it will be a graph that it is going downhill like that. Our tangent will be sitting like that with a negative gradient. It will be a negative gradient. Now if we take a number that is above 1.2, 1.67, let's say a 2 is above 1.67. So if again here I put the time to be 2, so we put a 2 here, it means I'm going to have a 2 here. So if we say 2 times 6 times a 2, I get a 12. And if you say 12 minus 2 is a positive 2, we get a positive 2. So it means our tangent or our graph is actually increasing. It has a positive slope. The tangent will be sitting like this. And you can see that this shape actually gives you the graph like that, the happy graph, right? And we say this is concave up. And the U here, we can see it here or on that diagram. So it means our graph will be concave up on that part. Another way in which you can confirm, if this graph has a minimum, you can use the second derivative test. So we can use here the second derivative test. So with the second derivative, we are going to take the derivative of the acceleration. Remember, acceleration in this case is our derivative that we took here. And if we take the derivative of this, we are going to have a 6 here, and the 10 will be a 0 there. So it means our derivative here would be a 6. And if you look at this number, it's a positive number, it is greater than 0. And we know that if we have the second derivative to be greater than 0, we will have a concave up, we'll have a graph that is concave up. And again, the U here gives us the shape of that graph. So we know that this point here is actually really the minimum turning point, or you can say the minimum velocity in this case, because we're applying it to velocity in this case. Now that we have confirmed that we have a minimum, we can then now go calculate the value of the velocity. So that means I'm going to take, so what I'm saying is that we know that this time occurs at the minimum. It occurs when the the graph has a minimum velocity. So I can use this time now to find the velocity. So it means I'm going to put this on my formula for the velocity, the one that we took the derivative for the velocity. So this means now I'm going to say here that at t is equals to 5/3, what we actually have, we have the velocity there from the formula to be v of 5/3. Then we're going to have a 3 here, 5/3 squared minus 10, 5/3 plus 4. And we can just put this on our calculator. So we're going to have a 3, 5/3 all squared minus 10, 5/3 plus 4. And this gives me a negative 4.33 meters per second. And again, this is not surprising. Remember, I said that the velocity can be negative. So this makes sense. If it was a speed, it shouldn't be negative. And for this question, you get 4 marks. I mean, as you could see, there's a bit of things that are involved in here. So we'll get a mark here for computing the derivative. Then we will get another mark for saying the derivative is equals to 0 here and solving for this t, and also are answering our final answer here, getting to the final answer. Now the last question says here, calculate the acceleration at t is equals to 2 seconds. Already we have an equation that defines acceleration from the previous question here. So we know that the acceleration is given by this. When we know that it's a function of time, don't we? So that means now here on 10 10.4, I'm simply going to say the acceleration as a function of time is given by 6t minus 10, and we are looking at it when t is equals to 2 seconds. And so this means now I'm going to have a 2 here, a 2 minus a 10. And really when you do this, it gives you 2. Because, I think I did this when I was doing my first derivative test. 12 minus the 10 then it should give you 2. But remember, this is acceleration. It will be measured in meters per second squared. Very important to remember those SI units and always put them there. Because when they mark your answer, they will mark the number and the SI unit, the unit that we use to measure acceleration. And of course, this is only 2 marks because you get a mark also for substituting in there. And really, that's how you do these questions. They can come in many ways, but they really ask the same thing. You just have to understand the fact that when you take a rate of change, it is actually the derivative. I want you to tell me if you are able to do the second question that is following this one. And if you guys are sorted, it means you don't need to do a video.